Welcome to the second video on Chapter 8, which is all about energy. So we saw in the last video, we talked about work, basically the going against gravity, against gravity, against gravity, right? And we saw the equation for that was W equals F times D, force distance. Work is equal to force times distance, right? And we saw our units for work, the joule. So very simple. And now we're going to move into something. Oops. Oh, my computer's running low on battery. I'm gonna go plug it in. Okay, got my computer plugged back in. Sorry. So let's take a look at power now. It's section 8.2, and power is going to be something, it's another branch of energy. So power. It's not another form of energy, but it's another subject within this huge domain of energy, okay? Because energy, remember, encompasses everything and is encompassed by everything. So we have work here. Now we're going to use power, which uses work. Uses work. Because as we'll see, now I want you to recognize something right off the bat. When you're looking there at 8.2, you're going to kind of, I hope, think back to earlier chapters where we defined what a rate is. A rate. Okay? Rate is basically anything over time. So divided by time. Divided by time, right? T for time. Always divided by time. So a rate is basically how fast something is being done in terms of time, and whatever that something is, be it how fast something is changing velocity or something like that, right? So acceleration. So now we're going to look at another type of rate, and a rate encompassed in the energy chapter called power. Okay, and power will come up in later chapters when we look at circuits and electricity and whatnot. But now we're going to define it as work done divided by the time interval, right? Time interval, don't let interval throw you off. Interval just meaning an allotment of time, like a certain amount of time. So I like to abbreviate as P equals W over T. So yeah, that's basically our power equation, and it's really self-explanatory. But really what we want to define power as, aside from numerically, is how fast work is done, right? Because we have a rate. It's a rate. So we're looking at how fast work is done. Okay, and then of course you can rearrange it to Pt equals W. I sometimes use that depending on what's given to you in the question. So that's pretty easy, I gotta say. And then let's do a little practice equation. I'll just think of off the top of my head. Let's see. Let's let's just set up our P, and then we'll say person X does 10 joules of work, right? So we want to put 10 joules of work up top, right? Because that's our work done. In a total of 5 seconds. 5 seconds. Okay? So we have two SI units. We have joules, which remember is a combination of newtons and meters. We have seconds, which is just seconds. It's another SI unit. And we know that P is going to be equal to 10 divided by 5, which is 2, right? 2. And now we have 2 Newton meters, or a joule, and 5 seconds. Sorry, 10 Newton meters and 5 seconds. What's our new unit? Well, it's a combination of joules and seconds, which is called the watt, or capital W. 2 watts. 2 watts of energy. And I'm sure you've heard the term watts with your light bulb and whatnot. Sorry, 2 watts of power. Excuse me. So I'm sure you've heard the term watts in term with your light bulbs in your house and your light fixtures. So that's where this comes into play. It's all about power and work, and it's a rate. And so always think power is a rate. So that's pretty easy, I think, and it's not too difficult to understand. So it's conceptually it's very easy. Now I want to throw a question out there that I've been thinking about when I've been planning this work video out in my head. I was thinking of some questions that you might get that would be advanced. So let me just think of this in my head. Let's go person X. Person X has done 100. So I don't know if the numbers will work out nicely. Watts of power. You know what? Let's make 100 a little smaller for simplicity's sake. Let's go 10. 10 watts of power after moving a brick 10 meters. Sorry, I haven't really planned this out all too well. Let's go with 1 meter, just for simplicity's sake. 1 meter with a force of 10 newtons. How long was he pushing or moving the brick? Okay, so that is a very complex question. It's not so much difficult, but it has a lot of moving parts. So first let's identify our players. We have person X, that doesn't really matter. But we have 10 watts. 10 watts. Let's definitely identify that as power. Power right off the bat, okay? 10 watts of power, there you go, of power. And 10. After moving a brick 1 meter, we got a distance, we have D. With a force, newtons, we have 10 newtons. Is that 10? Yeah, I put 10, didn't I? I can't even, I don't even know if that is 0 or not, but I'm just going to close it and call it 10. Yeah. 10 newtons, right? So we have a force, we have newtons. How long? What are we trying to know? We're trying to know a time. T, right? So let's go ahead and look at this. We don't have one equation that can solve this. We don't have one conglomerate equation that we can look at. But we do have two. We have work, and we want to know first, to solve our power, to solve our P equals W over T, which is inevitably what we want to solve because we need T, we also need to solve W, because we don't know W. We know P, but we don't know W. We don't know T. So we need one of these, W or T, to become known. And to make W known, because we want to know T, it'll never be known before solving for it. To find W, we're going to use our work equation, which is F times D, force times distance, right? So now we can go ahead and plug our numbers in. So we have work is equal to our force, 10 newtons. 10 times distance. What is the distance? 1 meter. 1, right? Equals 10. And what unit do we have? We have Newton meters, so we have joules. 10 joules of work. So now we have W is equal to 10. Now we can go ahead and look at our power equation. P, what's P? What is our P? 10 watts. 10 watts is equal to W, 10 over 10 joules over our T, which is our unknown. That's what we're trying to find. Our T in, let's call it seconds, just to be friendly with SI. Right? Now look at this. Look at this equation. It's so simple, right? We have 10, let me put watts. 10 watts is equal to 10 joules over T seconds. Well, I hope you've done it in your head, and I hope you know that it's 1 second. But I'll show you some algebra just to clear it up. Multiply both sides of the equation by T, and you get 10 watts times T is equal to 10 joules, and you get the exact same thing, 10 over T, so you know that T is equal to 1 second. There you go. So that is kind of a big conglomerate, multi-step, multi-function equation not equation, question that could crop up somewhere. I don't know. I've never really experienced that, but I think it was a pretty good question. I think it's something you should know because it kind of tests the knowledge of previous sections. It doesn't just kind of ask you to rote memorize one equation. So I think that's a great question. I think you should learn that. And I will be seeing you guys in the next video where we talk about mechanical, potential, and kinetic energy. Oops.